Good morning, everybody. Today we're going to do a video on bandsaw tune-up, and this is a 14-inch Rikon band saw. A 14-inch basically defines the distance from the blade to the uh, column, and that's typically how they measure them. But we're going to cover 5 points today. The 5 points are installing a blade on the flywheels, tensioning the blade, adjusting the upper and lower guide bushings, adjusting the table parallel to the blade, and then we're going to do a demonstration on blade drift. Okay, before we get started, we'll talk a little bit about the anatomy of a bandsaw. So I'm going to open up the upper cabinet, and this is the approximately 14-inch flywheel. There's one on the upper part of the bandsaw and one on the lower part. And obviously this is where the blade is located. This is blade guides down here. I'll open up the cover here so you can see a little bit better, but there are two side guide bushings and a thrust bearing. And basically the thrust bearing allows you, when you push, the blade is resting against that back blade guide, so it keeps it vertical. There are the same set of guide bushings on the bottom with a thrust bearing. And this crank handle on the side will allow you to raise and lower the guide bushings depending on the thickness of the wood. Generally, I try to raise these an inch or two above what I'm cutting so that I can see my work. In other words, if I lowered this all the way down, it's much harder to see the line on the work that I'm cutting. So that's a little bit of a description. Typical bandsaws are pretty much, they have these same components.
How long have you had this bandsaw?
This bandsaw is going on about 15 years old. I try to maintain it carefully, keep it tuned up, and that's the key to any machine, is like wood, flat, straight, and square. Okay, to get started, the first thing we're going to do is basically kind of describe how you put a new blade on a bandsaw. I'm going to take the tension off this, and I'm going to move this blade forward or backward a little bit, and I've positioned it in the middle of the wheel, and that's where a thin blade should be, in the middle of the tire. If you're going to put a big resaw blade on here, it's kind of recommended that the teeth are outside of this front edge. Now what I'm going to do is put the tension back on, and I'm going to spin this wheel by hand, and you can see that the blade moved in and out, and it's come back to approximately the middle of the tire, and that's where I want it to be.
Untension the blade again?
Well, a lot of bandsaws now come with a tensioning device. Some of them have it on top. This one has a lever that you just rotate, and it takes the tension completely off the blade. And this allows you to put a new blade on, and then in theory just retension it again. If you're going to put another 1/4 inch blade on, you can just retension it to where it was before, if that's the setting that you like. And we'll talk about tensioning here shortly. Okay, next we're going to give a demonstration on how to adjust the upper and lower guide bushings, and I'm only going to do the upper ones because the lower ones are a duplicate of it. I have a set of feeler gauges, feeler gauge that's 5/1000ths of an inch. That's typically what I like to use, which is about the thickness of a piece of paper. And normally what I would do is I'd unloosen the guide bushing and then bring it back, and I'm going to put this feeler gauge in here. And basically you can see that it's not falling down, and it's just barely touching on each side, and it's about, it could be 4/1000ths, it could be 5/1000ths. It's very, very close to 5/1000ths of an inch. Between 3 and 5/1000ths, which is more like the acceptable range. So after I've then lock the guide bushings down and do the lower ones the same way, and then there's a thrust bearing on the back, and the thrust bearing moves from front to back. And by now that the blade is tensioned, all I have to do is move this guide bushing right up against where this blade is right here, so that it just barely touches, or it's back a few thousandths of an inch. So if I spin the wheel now, you can see that none of the bearings are moving. If the bearings are moving, you're too tight. Now we're going to talk about blade tensioning. Now I do it the scientific way, but I'm going to show you in a demonstration after I do my scientific. I have a block of wood to set this device on. It's basically a tensionometer. Now I'm going to basically take the tension off this blade. I'm going to reduce the tension on the blade to where there is no tension on it at all. Okay? I'm going to put this device on here, raise this up just a little bit higher. I'm going to put this device right here, and it basically locks onto the blade. And the reason for the block of wood is this tensionometer has a pivoting point at the bottom. And what I'm going to do is just slide that onto the blade, but I've got to put a little bit of tension on this, so I change the dial. If I move this dial, the dial is going to move. So I'm just going to put a little bit of tension on it, and then zero it out. Now I've talked to a number of blade manufacturers, and there is no scientific exact reading. They give you a big range, 15,000 pounds per square inch to 25,000 pounds per square inch. Now, as Dennis zooms in on this, I'm going to start tensioning this blade. And you'll see the needle moving right now on the outer. It's 10,000 psi. And then I'm going to go a little bit further. And typically I try to do 15 to 17,000 psi. Okay?
That, or were you actually using the tension?
No, I was using the tensioning device on the top of the machine. Now what I want to demonstrate is for the person that doesn't have that. I'm going to put this square on the left-hand side of the saw. And I'm going to take my dial calipers over here, or anything to measure with. And what I'm trying to do is get a blade deflection of about 3/16 to 1/4 of an inch. And I'm just going to push on that about as hard as I can. And you can see that I deflected the square. And here's my digital calipers, and I'll just approximately, and I'm at 170 thousandths, which 3/16 of an inch is 0.187. So without getting down to splitting hairs, it's very close to 3/16. So I'll do it real. Now, I'm going to turn the saw on. I've got the blade guides adjusted. We'll close this for safety purposes, lock this down. And the last thing to do is check that, and you can do this anytime, but the blade is perfectly square with the table. Ta-da! Nothing squeaks.
Nothing touches?
Nothing touches.
No sound.
No sound. And this bandsaw is going on like 15 years old. So the final thing we're going to do is we're going to talk about blade drift. But you would think that I've done all these adjustments and everything, and this thing would cut true to the miter slot in the table. Well, guess what? It doesn't. And the distance from the inside edge of my miter slot to this line is 6 5/16 of an inch. Now, just freehanding it, I'm going to turn the saw on. If you, not moving the board, if you come over here and look at the miter slot, it's not very much, but the board is not parallel with the miter slot now.
And is that per blade, you think? Caused by the blade or the machine? In other words, if you did this on this blade...
I have a feeling it's caused by the blade.
I do too.
Saw is basically used for detail work and cutting out shapes and templates, and I just, no offense to Rikon, but the saw is 15 years old. The fence that came with it was a piece of crap. I didn't want to use it, so I just don't use it on the saw. That's all. If you don't use the fence, you don't have to worry about this. You can do 14.
Okay, we're just kind of wrapping up here, and you notice some of the subtleties. This guy has the slot to moving the blade in and out right here. and some of them have them right here. And what did you say the one that's out here, Ed? It's a pain in the what?
Ass.
Uh,
Literally, you have to take the blade and slide it in and then rotate it to get it. It's whoever thought about that had their head up the rear end. Okay, I mean
so
that is just stupid. I don't understand that.
Both the Agzani and my little Inca, this
Right.
is how it is, and it just seems to be.
So you just take the blade off and just slide it right in here. But it goes on so easy. By the way, on this saw and most others, probably I can put anywhere from a 1/16 of an inch blade up to a 1-inch resaw blade on.
And that's another thing that I would go ahead and open that up. Now, why is this important? This is kind of neat. We just Ed said he's never seen this before.
Yeah.
But why this is important is, notice this Rikon, I don't know if it's even the current ones, but it'll take a 1-inch blade, and as I understand, the 1-inch blade, if you want a carbide blade, the smallest they make is a 1-inch. So this guy could theoretically run a carbide blade, which is incredible. So, okay, that's enough.
By the way, this is a 2-speed bandsaw. There's a belt down here, and you can change on the pulley. And actually, you could cut metal with this if you wanted to. And over here, there's a belt tensioning device to tension the belt.
Drive belt.
The drive belt.
Like I say, this guy's got to be a fantastic value.
Right.
It
has all the features of a high priced bandsaw.
So what is your commission on Rikon sales, Ed?
50%. So, no.
Okay, cut for real.
Well, wait, one more
thing.
Don't be fooled by buying a brand name of something. I'll give you an example. Most all of the tools now are coming out of Taiwan and China. A few of them maybe in Europe, but for the most part, I've got machines in my shop that if you look at 5 brands, the only difference in the 5 machines is the color. But the price difference can be as much as $1,000 difference. So don't be fooled. Grizzly is buying the same machine that Laguna is selling for anywhere from $1,000 to $1,500 cheaper. And if you look at them and look at the specs, they're exactly the same. They're coming out of the same factory. So don't be fooled by, I have to have a Powermatic because Powermatic doesn't make anything anymore. Laguna doesn't make anything. They're just tool brokers is all they are, and they put their name on it and get a high price. So buyer beware. Okay. In our opinion. But the other thing to consider, the amount of use that we as a home shop type guy, you're never going to wear out these machines. For sure. These things are made to run 8 hours a day, 5 days a week. We don't do that.
Cut.
One other quick thing.
One more thing.
Removing the tension from the blade. This is a personal thing or whatever, but when I don't use the machine, I take the tension off the blade. I don't want the blade digging into the tires. Some people don't buy into that. Some people do. I figure, why not? And then if all I have to do is tension it, come back and move the handle back. Only one time have I turned the machine on when it wasn't tensioned. It didn't do any damage, but
didn't work.
I just don't like doing it.
Okay, we gotta go.
Cut.